Let's run through a machine learning portfolio project to land your dream job today. I've uploaded the full notebook and dataset in the description, so go there and have a play. What I want you to do is open up Python. Now this could be in any environment, whatever's best for you. Personally, I like to use Jupyter Notebook. Now following the link in the description will take you to this page here, where you can see data on rain in Australia. You'll be able to predict accurately whether tomorrow it will rain or not. This is a huge data set with about 10 years of daily weather observations, all the way across Australia. What I want you to do is go to this website, look at the columns, the rows, other people's code and the discussion, and get an understanding of the data. If you're logged in and have an account, then just hit download. Now within this analysis and this project, we're going to cover data loading, pre-processing, exploratory data analysis, EDA, feature selection, model training, evaluation, result interpretation, and even a prediction for a new input. What I've added here, and what I recommend you do, is add a bit of context to your data, to your project. What are you aiming to do and why? You'll see, once we've imported and explored and cleaned the data, we'll then train and test and evaluate our model. And finally, come to a conclusion on whether it will rain. All that being said, let's begin. First of all, what we need to do is import our necessary libraries. We're going to start with pandas for data manipulation. Then NumPy for numerical computations. And finally, we'll bring in some visualization libraries. All of these four should be the standard for any project. Once we have these, you'll note there's a few at the bottom that we hadn't covered in our last tutorial video. These are specifically for machine learning. What we'll utilize is sklearn, scikit-learn. I'm going to break this down and simplify it without going into too much depth, making this a very digestible and approachable project. Using sklearn, we're going to import the train test split. This will allow us to have some training data and some testing data. We're also going to bring something in a bit more complex but called a standard scaler. And what this will do, we'll just standardize our variables, meaning they're all the same. But don't worry, we'll get to that later. Then we'll bring in a simple imputer. Now that's just for handling missing values. Specifically today, we want to use logistic regression, and that's for classification tasks, yes or no, one or the other. So we will be able to predict whether it rains, a binary output. Finally, we need an accuracy score, confusion matrix, and a classification report. This will allow for model evaluation. Now, make sure that your notebook and your data is stored in the same file. I know mine is. And so using this, I'm going to import the data with pandas. What we've done here is more than just importing it. We've also loaded it into a data frame and then explored the head, which by standard is the first 5 rows. Now we have a lot to explore here, a lot of variables. Everything from date, and we can see that it's a daily report, to location, where in Australia, the temperature, evaporation, sunshine, wind gusts and more. Now I can tell there's 23 columns, but I want a better idea of the shape. We'll do that here. Wow, a very impressive and sizable dataset with over 145,000 rows and 23 columns. This may seem daunting at first, but don't worry, we'll take you step by step. What's very handy is getting some info, and we'll do that with df.info. We can see here for all the rows what their data type is and whether there's any null values. And we can see that there are. Now when you have a null value, there's a few things you can do. You can remove the row entirely or impute the value, meaning fill it with a mean, median or otherwise. In this case, what we want to do is impute it with either the mean or the mode. So let's dive into this. Any value that is null in a column will save under columns with missing. Now for each of these columns that are numerical, we want to impute it with the mean. If the data type is a float, we'll use the mean. If it's categorical, we'll use the most frequent. What I recommend is going through each line of code here and ensuring you really understand it. And if not, find a better way of doing it. Find your own way. From that very complicated code, we're going to go to a very simple line here. Is there any duplicated values? And there's not. Fantastic. What we can also do is check whether there's any particular duplicated values in any specific column. There. We can actually see that a lot of people reporting on the same days. Initially, this might be cause for concern. But what we can actually understand from this data is that there are multiple locations reporting on those same days. So actually, with that domain context, it's nothing to worry about. And we can proceed to the EDA. I wanted to see how many times it did rain tomorrow, so we ran a simple value count. Now our target variable is whether it rained. What I'd like to do here is visualize that on a graph. We'll use matplotlib to change the figure size. Now I did this because after I had visualized it with the count plot in Seaborn, it wasn't quite how I liked it. I wanted it a bit bigger. I changed the X and Y label and then I showed it. All we did here, and the crucial line of code, is we created a Seaborn count plot for the data in the data frame on the X variable of rain tomorrow. Now, very visually here, we can see that it often didn't rain tomorrow. More no's than yeses. Now I chose these 6 columns as what I thought initially might be interesting to explore in the effects of whether it rained. So let's run a .describe. Now on these selected numerical columns, which I had outlined here, by separating via a comma, I then wanted to run a heat map and see how strongly correlated they were. Now of course, everything with itself is fully red or 1. Meaning it's 100% positively and strongly correlated. Other things, less so, such as max temperature and humidity. We did this with a heat map on the specific columns within the data frame, running a correlation. Anot equals true, meaning it displays the values, and we centered it and made the color scheme cool warm from blue to red. This is all part of the exploratory data analysis process, and you actually don't need to do these specific charts or any at all. It just helps gaining a better understanding of the data. For example, say I was curious or perhaps asked by a stakeholder what the top 10 locations with the highest counts were. I could do this. Again, a very quick but yet impressive chart. I'll show you the code I use for this, and I won't delve too deep into it, but I want you to bear this in mind. Top locations was the variable that was assigned to the value counts with the head of 10. Then we filtered it just for the top, and we visualized this. And again, to bear in mind, it often doesn't rain tomorrow. But you can see how this does change across location. Here, we can get into the fun stuff, the machine learning, what you clicked on this video for, and what really will push your portfolio to the next level. These are the features I want to use. Feel free to use more, less, or your own. So let's assign these all to the variable features. I'll hit run. I want my X variable to be features, all of these. And my Y, my outcome, rain tomorrow. So I want to see the influence of X on Y. Now there was a bit of a problem in this. Rain tomorrow was yes or no. I wanted to change that categorical target variable to a binary output. This will prepare our target variable to a format more suitable for binary classification, such as that used within logistic regression. Very simple here. All we did is we changed rain tomorrow in the data frame to rain tomorrow in the data frame, but we replaced yes with 1 and no with 0. If I run this and check the value counts, you can see that it's worked. And again, 0 being no, it didn't rain more often than it did. Fantastic. You're doing really well. And we're almost towards the end. It's actually not too long to go at all. What's next is this line of code here, which does seem quite long, but don't worry, I'll break it down for you step by step. We're going to split the data into training and test sets. It's important in machine learning that you don't run everything on a single set of data. The reason you do that is that so you can test for over and under fitting. You want to see how it will generalize to new data. The training data is what it uses to learn. The test data is separated from the rest, and it doesn't look at that until the very end when it tests its outcomes and it has a little look to see if it was right. What we actually want to do is make sure the majority, therefore, is committed to the training set. We want to give it a lot of information. The more data points you have, the more accurate your predictions may be. Therefore here, we put test size as 20% or 0.2. The rest of it, the final 80%, will be committed to the training set. So we have a few things here, and I'll break it down further. We have a training set for X and Y, and we have a test set for X and Y. So X train, X test, Y test, and Y train. And this is just the train test split. We're going to bring in our X, our Y, and our test size, and then random state 42. What this means is just that every time you run this, you'll get the same response. You don't actually need to put a random state, and this final number is rather arbitrary. It could be anything you'd like. But here, we'll use 42 to make sure you get the same results. I've actually noticed here that there was no X imputed. It was just X is what I called it previously. That must have been for a previous video. So ignore that. It's just X and Y, which is essentially these up here. These variables are what we're pulling into our data set. So now we can standardize these features, and we mentioned that in the introduction. We had wanted to standardize it so that there'd be a better model performance. So a standard scaler will make sure all the features have a similar range. We just do this so it's consistent. Now how do you do that? We create a scalar instance. We then fit it to our training data in the X and the test. Finally, we can actually test the model. Let's do that here. Our model is going to be logistic regression, and we're going to fit it to that X scale data, meaning it's standardized, and our Y training data. So it's training only on the trained data for both X and Y. It's not considering at all the test data. It then makes a prediction using the test data, the scale test data, to ensure consistency. And what we can see from this is how accurate it was. We calculate the accuracy with an accuracy score, which looks at the Y test and the Y predict. See how similar it was. Let's hit run. There. 0.83. What this actually means is the model correctly predicts whether it will or will not rain tomorrow around 83% of the time based on these features we select. Now that's very impressive. Good. Initially, this is looking fantastic, so we can continue. To really assess how accurately our model is doing, we want to use a confusion matrix. This looks for true and false positives and negatives, ranging from -1 to 1. Let's hit run here, and this is the code you use. So this top cell here is how many true negatives there were, then how many false positives, how many false negatives, and how many true positives. You can look into this, and it might be requested by a stakeholder just to understand how accurate the model is. But for now, we're just going to skip past it. Importantly, we're going to look at these metrics in particular. We're going to evaluate with precision, recall, and F1 score. You can see here I've added some explanation in this portfolio to what each of these numbers mean. And feel free to pause and have a read through. And finally, we can look for a new feature, will it rain tomorrow? So for each of these, which I'd chosen as X, I added in new numbers. I had chosen these at random. If you really wanted to measure whether it rained tomorrow, you'd add in today's minimum temperature and so forth. I also hadn't included which location I was looking for, so it won't give an accurate depiction for specific places. Either way, I added in new values for each of these X variables. What I did then is I predicted, will it rain or will it not? And it says no. Not a surprise. We could probably bet that based on the fact the majority, it doesn't rain. Now, best of luck and try this yourself.